Hello everyone, how are you today? I hope you are feeling okay. Well, as you can see on my screen, you are going to learn about the anesthesia machine. This video covers parts and components of anesthesia machine, anesthesia delivery process, and anesthesia machine monitoring. Okay, next. So an anesthesia machine is used to generate and mix medical gases like oxygen or air and anesthetic agents. It is a complex collection of equipment. Some recently developed machines have highly complex integrated electronic systems and are usually called anesthesia workstations. And this machine performs four essential functions, that is to provide oxygen, to mix anesthetic gases and vapors, to enable patient ventilation, and minimize anesthesia-related risk to patients and staff. So the anesthesia machine here is used for respiratory support and anesthetic agent administration. Next, this is Boyle's anesthesia machine. This is the machine of Boyle's that was made by the British Oxygen Company or BOC in 1950s. And the original concept of Boyle's machine was invented by the British anesthetist Henry Edmund Gaskin Boyle in 1917. And actually, this machine was a modification of the American Quath-May apparatus of 1912. And now, it is the best known early continuous flow anesthetic machine. So this is the machine of Boyle's. We can see here the nitrous oxide cylinder, carbon dioxide cylinder, and then oxygen supply for gas-driven ventilator. And then this is the TEC Mark III vaporizer. This is common gas outlet and pressure relief valve, back bar, flow meter, blood pressure gauge, and this is the needle valve control knob, and this is the cylinder pressure gauge, and this is the oxygen cylinder. Alright, next we move to the modern machine, or we call it as Anesthesia Workstation. Well, though a lot of changes have been made to the original design of Okay, now we move to modern machine, or we can say Anesthesia Workstation. Though a lot of changes have been made to the original design of the Boyle's machine, the basic structure remains the same. Now let's check the front part here. We have oxygen flush button. We have breathing system, that is rebreathing bag, and carbon dioxide absorber. And this we have load controls, and this bellows assembly, and the next is suction regulator. This is the display And this is the auxiliary oxygen flow meter. These are flow meters, and these two are vaporizers, and this is the system switch, and this is the secondary gas supply pressure gauges or cylinder gauges, and this is the primary gas supply gauges, usually pipeline. And now looking at the back side, we have electrical outlets with circuit breakers and main circuit breaker. And the next is oxygen power outlet. And these are pipeline inlets. And the next is waste gas receiver. And this we have cylinder yokes. And these are cylinders. And this is scavenging connector. Okay, now we go to the components. So the basic anesthesia delivery system consists of oxygen source, that is a central distribution system to help breathing, and this is oxygen flow meter. It is to keep the flow of oxygen at a set point to keep everything consistent, and this is a vaporizer, that is to take the liquid from the anesthetic and transforms it into a vapor so that the patient can inhale it. And this is the breathing circuit. It is to deliver a mix of oxygen and anesthetic gases and eliminate carbon dioxide from the exhaled air. And this is the scavenging system. It removes any excess gases from the machine and prevents it from contaminating the immediate atmosphere. Okay, so the next one is Modern Anesthesia Machine. This anesthesia workstation consists of basic anesthesia unit that you have watched in the previous slide. We have gas supply or gas delivery, and then flow meters, vaporizers, breathing circuit, and scavenging system. Anesthesia workstation also has advanced ventilation, and it also has anesthesia and patient monitoring system, and electronic medical records. Alright, next we move to anesthesia delivery process. This is the functional schematic of an anesthesia machine or anesthesia workstation. You can see this picture. And here is the process. So the anesthesia machine receives medical gases from a gas supply through gas inlet, that is to enable an optimum gas exchange, and then it controls the flow using the flow meters, of course, and reduces the pressure of desired gases to a safe level. and then transform the gases into the final gas mixture through the vaporizers, and next deliver the gases at the common gas outlet to the breathing circuit connected to the patient's airway. The next is Anesthesia Machine or Anesthesia Workstation monitoring. So you're going to learn how to report this based on the monitor. Start from this, we have heart rate or pulse. So you can say her heart rate is 120 beats per minute. And the next is blood oxygen level. His blood oxygen level is 95. This is arterial blood pressure or invasive blood pressure. His ABP is 120 over 70 millimeter of mercury. And the next is respiratory rate. His respiratory rate is 55 breaths per minute. And this is temperature. His temperature is 37 degrees Celsius. And the next is non-invasive blood pressure. His NBP is 80 over 50 millimeter of mercury. Next, EtCO2, or we call it as end tidal CO2. His EtCO2 is 34 millimeter of mercury. And the last one is MAP. That is mean arterial pressure. So you can report it to the doctor like this. His MAP is 90 millimeter of mercury. Thank you very much for watching and see you in the next video.